Bam! Mr. Tarrou. In this video, we're going to be solving a system of equations that involve logarithms. But first, I want to say thank you to all of my students at St. Pete High. Never actually stated online where I teach, but it's where I've been teaching now for 24 years. And you all are the reason why I enjoy going to work every day. It's the purpose of my career, and it's honestly, you make my career. You're the reason why I love it. And also, I want to say thank you to everybody on YouTube that has continued to watch my videos over the year. I've really enjoyed all the positive feedback, mostly, and everything, all the nice comments and notes that I've gotten, again, through this week of teacher appreciation, this weird staying at home, quarantine, distance learning thing that we are all trying to get used to and hopefully be successful in. I am struggling with this probably just as much as some of my students. I may have nearly 700 videos on YouTube, but you really need that in-class, in-person interaction, two-way communication where you can ask questions, read body language, see if kids are struggling when you're saying something. It's really a challenge, and I'm very proud of you for all the work and determination that you have shown over this situation that we have to get through. So, for celebration, we're going to do this really cool problem. I've seen this recently. All the years I've taught logarithms, I've never seen a question that involved a system of equations. It's something that I saw in an exam recently. I changed the basis, changed the numbers, made it my own, and we're going to tackle this problem. What do you do when you have a system of equations log base 2 of 8x is equal to 1 plus 2 log base 2 of y? Another equation in our system is 1 plus log base 8 of x is equal to log base 8 of 10y minus 12. Okay. Well, first of all, don't panic. If it's your homework, you got time to think about it. If it was on a test, hopefully you've seen one of these before, your first experience on an actual test. Don't panic. Just kind of go back into your toolbox. What have you learned? Even if it's going to require skills that you haven't necessarily used in quite a while. How do you solve an equation that has logarithms in it? Well, you generally need to find a way of rewriting that equation to, say going back into exponential form. Maybe that's probably the reason why the equation has logarithms in it, because in that initial form, it's not necessarily something that you can just step right into and solve, immediately. So how are you going to do that? Well, there's a couple of ways. Either we can take this equation and write it as log base 2 of 8x minus 2 log base 2 of y is equal to 1. Now, if we do that, we see we have a subtraction of 2 logs of the same base, and we can therefore bring this together after bringing this 2 up as a power, because you can't use sort of that division property for condensing logarithms unless your coefficients are 1. So we can write this as log base 2 of 8x minus log base 2 of y squared is equal to 1. Now we can bring this together and write it as a single logarithm and say that we have log base 2 of 8x minus y squared is equal to 1. And then step into exponential form and say that we have what? We have 8x over y squared is equal to, now what do you get as an answer from a logarithm? You get an exponent. This is the base in exponential form. This is your exponent in exponential form, and this is what the answer is. So this log base 2 of 8x over y squared is equal to 1 can be rewritten as 8x over y squared is equal to 2 to the first, which is just going to be 2. Okay, voila. Now, with our second equation, we can look at this in a different fashion that you can go through to write these equations in a format that do not involve logarithms. What you can also see is that we can think of, well, let's see here. Can we write a logarithmic expression that has a base of 8 that gives an answer of 1? So can I write something like log base 8 of something that's going to give me an answer of 1? Well, 8 to the first power, remember this, I'm thinking of this as being like the answer from the logarithm. 8 to the first power is equal to 8. So we can write 1 as log base 8 of 8, and actually we could also write this one as log base 2 of 2. And that is another way of approaching this problem. I'm looking at each of these, kind of giving you a different skill or different way of looking at these. And when we do that, now we can get a piece of chalk long enough to not scratch the chalkboard. Now when we look at this, we can say, well, here we have log base 8 of 8 plus log base 8 of x. We have a sum of logarithms. Logarithms give us exponents. When do you add exponents? You add exponents when you multiply like those like bases. And our like base is the base 8 of our logarithm. So we have log base 8 of 8x is equal to log base 8 of 10y minus 12. So now that says, okay, if we have one term on each side of the equation, and that is involving a function of log base 8, which is a one-to-one function, so the only way that these expressions are going to be equal is if what's inside each of those logarithms are equal. So now we have 8x is equal to 10y minus 12. And actually all these terms are even. So I can write this, I can divide both sides by 4 and write this as 4x is equal to 5y minus 6. Okay, so now what we have is we need to take these two equations, which now we've moved out of the world or realm of logarithms, and just kind of like we're just looking at algebra. Now, I'm going to go ahead and bring this y squared over to the other side. And while I took this expression and divided everything by 2, just because I'm rolling with it, even though I made this example and I had this 4x is equal to 5y minus 6, when I look at this and say 2y squared is equal to 8x, actually this is our perfect expression that we can use for substitution, and that's how we're going to bring these together. We don't have two linear functions, so combining them, and this has a power of 2 and it's a power of y, I think it's just going to be neater for us to look at the system of equations with substitution. So what we're going to do now is that solving systems by substitution that you learned back in, maybe Algebra 1, and do that. We're going to bring these together by saying 8x is the same as 10y minus 12. Okay, so now got our blue out here, differentiate these. We have 2y squared is equal to 10y minus 12. Well, I guess I could have divided both sides by 2. So let's do that now. We have y squared is equal to 5y minus, 6. Set this thing equal to 0. So, yep, I made a sign error, didn't I? If we take negative 6 and add it to the other side, it's a plus 6. Take 2. Yes, we're going to bring that negative 6 over with addition, not subtraction. Okay, now we are going to, again, factor this quadratic without a copy error, and we have factors of positive 6 that add to 5. We're looking at y, minus 2 times y minus 3 is equal to 0. We're going to set each of these factors equal to 0, and we have y is equal to 2 and y is equal to 3. I was pausing because I have made this example ahead of time, and I knew that there was 2 points that were going to work. And why did I pause? Actually, I probably should have left that up there. How did I, in my mind, start to realize, hey, wait a minute, this is looking different? Is it just because I made my example? Well, I knew there was going to be 2 coordinates that were going to be solutions to this problem. And whether you do it now or at the beginning of the problem, which really probably would have been a better idea for me, whenever you are solving equations that have, let me get some red chalk out here. Whenever you're solving for equations that have a lot of restrictions, or any restrictions for that matter, on their domain, you need to check that domain and make sure that you don't end up with any extraneous solutions. Remember, you cannot take a logarithm of a negative value. What you get from a logarithm is an exponent, and the base of that exponent is the base of that logarithmic function. Exponential functions and logarithmic functions are just simply inverse math operations, and you can't have exponential functions with a negative base. So you're not going to take a positive base, raise it to any kind of exponent, and get a negative answer. No, you can only log, regardless of what the base of the logarithm is, a positive value. So when you look through here, we have that, when you look at here, we have, well, okay, y has to be greater than 0. Well, here we have the variable of y being used again, and 10y minus 12 has to be greater than 0, which means that 10y has to be greater than 12, not 10, 12, so y has to be greater than, well, basically 1.2. We have a y value of 2 and a y value of 3, so both of these values of y are going to meet the domain restrictions for this system of equations. And just like that, all right, we have the x as well. So we have, in this log base 2, we have an expression of 8x, and we have an expression of x. The 8, in terms of domain, is not going to make any difference. We also have that x has to be greater than 0. So any solution that we come up with for the system of equations is only a valid solution, not an extraneous solution, if y is greater than 1.2 and within each of the coordinates we come up with, x is greater than 0. So both of these are going to be okay for the domain of each of these functions. Well, when we have a y value of 2, what is our x going to be? Well, what's the easiest equation that relates the variable of x and y together? It seems like, well, I guess here we have 8x is equal to 2y squared, except now we're going to say that y is equal to 2. So 8x is equal to 2 squared is 4 times 2 is 8, so x is equal to 1, satisfying that. And we have one coordinate of 1, 2. And now we're going to use that same relationship between x and y with a y coordinate of, or value of 3, and we have 8x is equal to 2 times 3 squared. That's 8x is equal to, 3 squared is 9, 9 times 2 is 18, and x is equal to 18 over 8, or of course that can be reduced down to be what? 9/4. So our second coordinate is equal to x of 9/4 and a y value of 3. Now, okay, good. That is checking off what I got in my pre-notes. By the way, when I made these notes, I eliminated the variable, not the variable, but I eliminated the logarithmic functions both times in this fashion, where I wrote this one as log base 2 of 2. But as I started this video, I thought, hey, wait a minute, I can just bring this log base 2 over with subtraction and find another way of rewriting that equation so it does not have a logarithmic function in it. We know that both of these points work with the domain that we identified. It's also a good idea to take these and plug, of course, the value of 1 and 2 into our first equation along with the coordinate of 9/4 and 3. Basically check each of these coordinates in each of these equations. That will check out. So I'm Mr. True. Bam! Go do your homework, and thank you for watching.